This is lesson 4.5, solving quadratic equations by finding square roots. We're continuing to solve quadratic equations, and last time when we solved quadratic equations we used factoring to find the solution. And so here's an example of what we did last time. When we factored this, we said x squared plus 0x minus 169 equals 0. We put in the 0x because there is no b here. We're missing the b that goes with the bx. So we're looking for something that multiplies to 169 and adds to b 0. So the factors that are going to work are going to be positive and negative 13. So x plus 13 and x minus 13 equals 0. Those would be my factors. 13 times 13 is 169. 13 plus negative 13 is 0. So then when we solve this, the solution is the opposite. So x plus 13 gives me a solution of negative 13. And x minus 13 gives me a solution of positive 13. And that's how we worked this out. So today we're going to do a different method. So if we cannot factor it, we factored it before, but what if we cannot factor it and there is no b? So we have the ax squared and we have the c, but we have no b. Then we're going to use square roots. Okay? So before we start using square roots, let's talk about square roots and how to simplify them, because that's going to come up when we get to the ends of our problems. So if you'll recall from probably Algebra 1, you simplified some square roots. You might have even learned this in 8th grade math. And to simplify the square roots, we know that 28 isn't a perfect square. So the square root of 28 is not something that just easily pops out and we have an answer for. So what we're going to do is we're going to factor this or break it down into the parts that make up 28. So I could say 28 is 4 times 7, and I can rewrite this problem as the square root of 4 times the square root of 7, because 4 times 7 is 28, and if they're both under the square root, then the square root of 4 times the square root of 7 is the square root of 28. The way this works for us is that the square root of 4 happens to be 2. So we have 2 times the square root of 7, and this is the simplified form of the square root of 28. Now at first I don't think you're going to see the point behind this, but as we go through problems solving quadratics, I think it's going to start to come to you. You'll see why that's important. So let's try another problem. What if I want to simplify the square root of 192? Well, last time I had 4 and I had 7, so let's see. Does 4 go in 192? If I take 192 and I divide it by 4, 4 times 4 is 16. 19 minus 16 is 3. Bring down the 2, that's 32. 4 goes into 32 8 times, so yes indeed, 4 and 48 multiply to give 192. And I know that 4 is a perfect square because its square root is 2. What about 48? Can we break 48 down into anything? More specifically, can we bring it down to something that's 4 times something else? So let's see, 4 goes into 48 12 times. Okay, so I have a 4, and I have a 4, and 12 can break down, and that would be 4 times 3, so I have a 4 there also. So it may seem strange to you. Why am I trying to do the square root of 4? Why am I trying to break this down into 4? Well, 4 is the first perfect square that comes to mind for me. If 4 doesn't work, we probably would try 9, and if 9 didn't work, then we might try 16. But what we've got right here is the square root of 192 is the same thing as the square root of 4 times the square root of 4 times the square root of 4 times the square root of 3. So square root of 4 times square root of 4 times square root of 4 times square root of 3. So the square root of 4 is 2. and this square root of 4 is 2, and this square root of 4 is 2, times the square root of 3. And 2 times 2 times 2 is 8 square root 3. So 192, the square root of 192, simplifies into 8 square root of 3. Now there's some other ways to do this. If you have trouble simplifying, check with me or Miss Smith, because we have some tricks to help you if you're having trouble. But always try 4 and see if it works. And if 4 doesn't work, then we would try 9. Okay, for the next example, I have the square root of 35 divided by 36. The first thing you want to do anytime you have a fraction is separate the numerator from the denominator. So the square root of 35 over 36 can be simplified into the square root of 35 divided by the square root of 36. And that's a good simplifying tool because the square root of 35 does not simplify, but the square root of 36 is 6. So this is the simplified form, the square root of 35 over 6. And the reason this is a good thing is because there's not a square root anymore down here in the denominator. It makes for a cleaner, or prettier is what I usually say, kind of problem. Okay, so let's see if we can use this to solve. We're going to do the square root method. The square root method has an x squared term, and it has the constant. So recall if we had ax squared plus bx plus c, we're going to have the ax squared. The bx term is missing, but we have the c. And in our case, the c is going to be on the other side of our equal sign. So that's what sets it up for square root. Alright, so if this is what we've got, the way to get rid of a square, x squared, is to take its square root. Square root is the opposite of square. So if I take the square root of something that is squared, then the square root cancels the square and just leaves us with x. And the square root of 169 is going to be 13. Now, this answer, the square root of 169, could be 13, or it could be negative 13. So we're going to put a little symbol that you may not have seen before called the plus or minus sign. So my solution, x equals plus or minus 13. Or if you feel like you need to be more specific, you can say that means x is 13 and x is negative 13. But if you write it with the plus or minus symbol, then you don't have to break it down. It's a shortcut. Okay, let's try another one. X squared equals 84. So how do I get rid of x squared? I'm going to take the square root of both sides. When you take the square root of x squared, it is going to get rid of the square. So that leaves me with just x. And this is going to be plus or minus the square root of 84. So now you can see we're going to have to simplify like we did in the beginning of our video. We're going to have to simplify 84. So how can 84 simplify? Well, let's see. Is it divisible by 4? Yes. 4 times 21 gives me 84. And 21 is 3 times 7. So x equals plus or minus the square root of 4 times the square root of 3 times the square root of 7. Notice that once we've used 21 to find its factors, it's not one of our factors anymore because it's been broken down. So that's why we just have 4 and 3 and 7. So now I'm going to say the square root of 4 is 2. The square root of 3, that's not a perfect square. The square root of 7, that's not a perfect square. So I'm going to take these two and bring them back together. 3 times 7 is 21. So x equals plus or minus 2 times the square root of 21. And that's our solution. Now notice again in this problem, there was no b. If we had ax squared plus bx plus c, we have the x squared term, but there is no x, so there is no b. Anytime you're missing the b, you can use this method. It's called the square root method. Alright, let's try another one. This one's got a little bit more to it. Anytime you're trying to solve for a variable, you have to try to get everything else on the other side. So I'm going to start this process by subtracting 8. So 15 minus 8 is going to be 7. Then I still need to get t squared by itself, so I'm going to multiply by 20. And I'm going to multiply by 20 because that'll make my 20s cancel. So now I'm left with t squared equals 140. How do I get rid of t squared? I take its square root. The square root of t squared leaves us with just t. The square root of 140 is going to be plus or minus the square root of 140. And then we're going to see, can this break down, and what will it break down to? So, is 140 divisible by 4? It looks like all these are working out pretty well for me so far. Let's see, 3 and 5. So 4 times 35 is 140. 35 will break down into 5 and 7, so we don't need the 35 anymore because we've broken it down. So t equals plus or minus the square root of 4 times the square root of 5 times the square root of 7. We know the square root of 4 is 2. The square root of 5 and the square root of 7 are not perfect squares, so we're going to multiply them back together. And so t is going to be equal to plus or minus 2 times the square root of 35. Alright, I have one more example, and then I have one for you to work on your own. So, to get my x squared part by itself, this is the part right here. This is the part that's squared. I want to get it by itself. So to do that, I'm going to add 18 first to both sides. So that leaves me with 7 times x minus 4 squared equals 10 plus 18, which is 28. Then I still want to get this part by itself. So I'm going to divide both sides by 7. So x minus 4 squared equals 28 divided by 7, which is 4. Now, how do I get rid of the square? I'm going to square root both sides. The square root gets rid of the square. X minus 4 equals the plus or minus square root of 4. X minus 4 equals plus or minus 2, because the square root of 4 is 2. Now what do? I need x by itself. So I'm going to add 4 to both sides. So right now my solution is x equals plus or minus 2 plus 4. And it's very tempting to stop right there, but this means we have two solutions. One solution is positive 2 plus 4, which is going to be 6. Another solution is going to be negative 2 plus 4, which would be x equals 2. Hopefully I'm not in that dosary sign. So the two solutions we have here are x equals 6 and x equals 2. Okay, so we have several practice problems, and all the practice problems are different. Make sure after you do this on your own problem, show it to Ms. Smith or I in class. Make sure you do plenty of practice problems because all of the problems are different.